Dear learners, welcome to the UGC lecture series on laser physics. In the earlier lectures, I had explained that laser is a special type of light. It is an extraordinary light. It is extraordinary light because light gets amplified. What is this amplifier? Already you are all very familiar with amplifiers in a very big function, wedding hall or in a protest march or in the political march. You will see somebody will speak and there will be a big loudspeaker which amplifies his voice. That means you give certain input. Suppose you give an input of 1 unit, what comes out is a 10 unit, because there is a certain device which is capable of producing amplification or enhancing the energy or the power of whatever you have given. That is an amplifier. In laser, the funniest thing is you are giving a certain light at one point, you have a device which amplifies the light. It amplifies the light based on one single principle of stimulated emission. That is all what you have seen so far. But most of the lasers that are available in the market are not lasers. It may be surprising for you. They are all oscillators. That means there is a fundamental difference between oscillation and amplification. I can give one very simple example. An amplifier for your voice is a big microphone. You speak before the mic, and then what comes out is amplified voice without any distortion. It has been enhanced only in the power. That is an amplifier. That is an amplifier of your audio signal. On the other hand, maybe you have seen microwave. In the microwave, what happens is, the purpose of the microwave, many are maybe very familiar. You have a cup of coffee, you want to warm it up, you just put in that one, close the door, switch on. Then after some time, when you take it out, coffee is ready at a right temperature of your choice. What has happened is, the microwave has produced certain microwave energy which had been absorbed by the water in the coffee, and since it has been absorbed, it gets warmed up. Now listen, what has eventually happened is warming up of our coffee, but that came from the microwave which was produced in the microwave generator, and the microwave is an electromagnetic wave which you did not feed in. All that you did is you plugged it for your 220 wall plug voltage. That is all what you did, and the device is capable of taking the energy at 220 volts 5 hertz frequency electrical power, converting into a microwave which is capable of warming up your coffee. This microwave has been produced, and the microwave that you have on your table in your house is an oscillator. That is, a microwave is an electromagnetic wave that has been generated by that instrument. So, that is a oscillator. A mic is an amplifier. In a similar fashion, we are going to do amplification of light signal or oscillation of light signal. So, laser can be converted into an oscillator or an amplifier. At the beginning, when the laser was fabricated, designed, people were struggling to get a laser. They thought that laser will be mostly an amplifier. So, if I put a signal of 1 unit of particular wavelength of light, I will get 10 unit of signal or amplified signal of the same frequency. That is what the beginning expectation. But in due course, we all had realized that the particular device laser is capable of generating electromagnetic wave from a set of frequency from infrared to visible to ultraviolet to far ultraviolet. It is capable of generating electromagnetic wave of different frequency based on the design you have employed. Or in a simple fashion, laser can be an oscillator or an amplifier. An oscillator means you need a certain condition that is called a threshold condition for laser oscillation. What do you mean by threshold? You all in your house, you have a threshold in your house. That is, suppose you are living in a flat where there are so many rooms, so many houses, so many apartments. There will be a way to entrance, wave to the first floor, second floor, third floor. Imagine a milk vendor comes and leaves a milk packet in your house. He will just walk up all the time, and then he will stand near the threshold, ring a bell, give a milk packet. The threshold is a defining wooden frame which will define that those who are inside are the inmates or the owners of the house, those who are outside are strangers or vendors. So, that is a barrier, that is a defining place, defining wooden structure which is called a threshold. That means, those who are inside are inmates, those who are outside are strangers. In a similar fashion, there are certain conditions for producing oscillation. Only those conditions are met. There are certain essential and sufficient conditions to be met before you produce a laser generator, laser oscillator, an electromagnetic wave, a coherent electromagnetic wave generator. Let us see both picture. All these things I have already explained. I will pass on to this one. I straight come to laser oscillator. In a laser oscillator, a broadband spontaneous emission generated within is amplified by stimulated emission, and this process is repeated over and over again for a narrow band of frequencies by the feedback provided by the resonator mirrors. Let us take a look at this one. This represents a typical schematic diagram of a laser oscillator. In this case, you have got two mirrors and there is a small chamber, rectangular chamber, and there is a pump source also, which here not been shown. In the rectangular chamber, you have certain medium. All those aspects I have already explained in the earlier lecture. I take it from there, take it from there on. In the rectangular small chamber, you can have a gas medium, liquid medium, or a solid medium, or even a semiconductor medium. So, that is the essentially source of electromagnetic wave. That electromagnetic wave can come only from some atom or some molecule, whatever it is. Then you pump it, you produce excitation on the atoms or molecules or ions which constitute the gas or a liquid or a solid or a semiconductor. Once you supply energy, the supply of energy mostly electrical discharge, sometime or half the time it may be an optical excitation. There are few other sources of excitation, let us not bother about them. Majority of the lasers work under pumping condition, the pumping condition may be electrical discharge or optical discharge. These are the most common. Let us focus on this one. I shine light. Imagine that this rectangular one is a ruby rod, which is a very famous, the first laser to be done. I imagine that this rectangular rod represents the ruby, the jewel, converted into a small cylinder, more of the size of a chalk piece, which you are all familiar. It may be about 10 centimeter in length, 1 centimeter in diameter. The two sides are made really flat. That is a medium, the solid medium. Then I shine intense light on this ruby solid. The ions in the ruby, which is aluminum oxide, absorbs the energy from the radiation I gave in, get excited from one energy level to another energy level. Now, recall whatever I have said in the earlier lecture. We excite the atoms, molecules or ions from one energy level to another energy level, then they stay there. We excite so hard that you produce population inversion. Under the condition of population inversion, what would happen is the atoms or ions or molecules which are excited will come down, producing two things: spontaneous emission and stimulated emission. Both process I have already explained. I do not want to go back. You will get spontaneous emission and stimulated emission also. Now, with this in mind, go back to whatever I have mentioned here. In a laser oscillator, the spontaneous emission that is generated from E2, higher energy level, to E1, when the ions come down from E2 to E1, you will get spontaneous emission coming from everywhere, in all direction, because it is spontaneous emission. That is the meaning of spontaneous emission. Remember, I told you spontaneous emission is something very similar to people in a big bazaar. They go run around here there, they stop, they smile, they chat and then they move. So, there is no specific control on this one. This is the spontaneous emission, but this is how the story begins for laser 2. The spontaneous emission generated within is amplified by stimulated emission, because the stimulated emission needs some seed. That seed is spontaneous emission. This stimulated emission, go back to whatever I have given, the stimulated emission will go, the spontaneous emission will be random. Few spontaneous emission photons will produce stimulated emission in one direction. Then this will be produced, this will lead to higher stimulated emission, a little more amplification, and then there are two mirrors. Just see these mirrors. There are two mirrors which will send the photons to go back. The stimulated photons are compelled to go back, go through the inverter medium, interact with them and produce further stimulated emission. That is, from R1 they go back to R2. R1, R2 represents reflecting mirrors. Then in R2, plenty of stimulated photons fall on it. The instrument designer will say, this is not sufficient for me, go back, produce more and more stimulated emission. So, the photons will be going back and forth, and eventually after some time you will have sufficient number of stimulated photons, some part of them will come out as a laser. Now, let us see a little more, just let us start with a little more mathematics. Let me, already I have explained, a laser oscillator starts with the seed of spontaneous photon. These are generated within the medium. They get amplified by stimulated emission, and then this process is repeated over and over again, but this is not repeated for every frequency. For a narrow band of frequency selected by the resonators. I repeat this one, the resonator is capable of selecting a particular range of frequencies, and that particular range of waves alone is fed back for further amplification. This is a property of resonator mirrors. How do they do all this one? What is the property or what are the properties of resonator mirrors? We will see later. All that you need to know is resonator mirrors are capable of selecting a particular frequency and sending them back in certain direction, in certain phase. This is something very similar to recruiting soldiers from the common young healthy adult. Just imagine that one, then you will, I go back to this one. Suppose we need 10,000 people today or in this particular month for the army. They will make an announcement that all able bodied men in the age group of 22 to 28, you can come and try to become soldiers. We will offer you good salary, we will offer you so much many things, and it is a matter of pride also to become a soldier. All these offers will be made. Adult, healthy, robust adult will go and be ready for recruitment. Then listen carefully, and this is exactly what is done by laser resonator here. What is being done by army recruit is done for the stimulated photons by the resonator mirrors. So, let us go back to the army recruitment. Out of 1,000 people who are selected for today's screening, the experienced general or lieutenant general, he would allow all the 1,000 people to run in a ground, go around. They will ask the people to go 10 times. Out of that, 90% of them will fall, will not be able to run 10 rounds. Eventually, you will have only about 20 of them or about 100 of them will be capable of going for 10 rounds. So, that is the first selection. Then second selection, they would be compelled to climb up the rope. When the people try to climb up rope, out of those 100, 20 of them will fall down. So, you have only 80. Remember, these 80 will be more or less of same stamina, same height, same body weight. So, you have made already a selection by repeated process of training, repeated process of strenuous filtering. This is exactly what the resonator mirrors. In the same fashion, after few days of training, examination, going through strenuous exercises, out of 1,000 people today who came in the morning for joining the army, eventually the lieutenant general will select only 20 of them. So, it is a selection process is very strenuous. In a similar fashion, in a laser resonator, a bunch of photons of different frequency, different phase, different direction will hit upon the resonator mirrors. The resonator mirrors will make them go back and forth and eventually select only a particular narrow band of frequency of light of only one specified direction, only one specified phase. That is the purpose of resonator mirrors. That means, the coherent properties are essentially brought about by resonators. The resonator has dual purpose. First thing, it provides a feedback for further amplification and also provides frequency selection. Now, suppose the number of photons that are stimulated by repeated iteration, they have only certain particular frequency, particular direction, particular phase. Let us start from here. If n is the number of photons that start arbitrarily at some point Z1, remember we are looking at the situation of photons at some arbitrary point. We do not know Z1, where just you can choose any point. Imagine if n is the number of photons that start arbitrarily at point Z1. It will grow up in intensity as exponential gamma L Z1. That is, it will grow in intensity where exponentially all this growth will be exponential. Then when it comes to the point of mirror R1 mirror, what we will have is the intensity or the number of photons will be n exponential gamma L Z1. Now, what is this gamma? To understand this one, let us go back a little, then I can explain what it is. What is this gamma? Let us consider this one. We have already seen in thermal equilibrium, E2 is higher than E1. E2 is the higher energy level, E1 is a lower energy level. Correspondingly, N1, the number of atoms in E1 is greater than number of atoms in E2. This is the thermal equilibrium condition, which you have already learnt in early lecture. This is the ordinary condition, this is the thermal equilibrium condition. Under this condition, let us see. First thing, let us see under ordinary thermal equilibrium condition, then we will see what would happen in non-equilibrium population inversion condition. This thermal equilibrium condition already you are all familiar. Population inversion condition is something new which is specific, exclusive for laser process, which you are learning. So, let us start from what you knew very well. Any spontaneous emission signal of intensity I naught represents an intensity with some symbol, that is all, I naught, and this is at the wavelength lambda and it has a polarization. All these photons put together produce, let us say, an intensity of I naught. Then it will get attenuated because of absorption and scattering, and this is given by Beer-Lambert's law. I naught by I is exponential minus alpha L. Minus alpha represents the absorption coefficient. This is something you must have studied in undergraduate. If I send a light, I put a, just imagine a color paper you must have seen, green color paper, yellow color paper. I suppose I send a white light, I put a green color paper, what comes out will be a left out green alone. Most of the red light or blue light would be absorbed. How much it is absorbed? All these calculations. So, suppose I put I naught is the intensity at green, let us say green wavelength is 530 nanometer. What comes out is I have put a thin green paper, then what I would get is, I get out the resultant is I, what I gave, the input is I naught, output is I, the ratio is given by exponential minus alpha L, where alpha is absorption coefficient, L is the length of the thin paper. This is an experiment you must have done in undergraduate and it is easy to understand. This is the situation in ordinary thermal equilibrium condition. This is all what we know until the laser came in. Let us go to the next term. Let us go to the next term. Suppose we have been able to produce population inversion. watch out, in the laser process we always excite so hard that you get inverted medium or population inversion. Under that condition, N2 becomes greater than N1. Here again, the growth of intensity, remember, in the earlier condition you get attenuation or absorption or loss of intensity. In this case, the intensity grows again exponentially. It goes exponentially in signal strength due to amplification. In the earlier case, in thermal equilibrium condition, there is attenuation, absorption, loss. In population inverted condition, you have amplification or increase in intensity, and this is because of stimulated emission occurs only for that particular wavelength, particular direction and particular polarization. That means, all that you have to do is imagine that you have a medium. Imagine I have a green light, I have a special medium which is capable of amplifying. Then what would happen is, if I naught is a light intensity at 530 nanometer, I have a amplifier, the amplifier length is L, then what comes out will be I. It would have increased in intensity. So, I would say the intensity has gone up, then it should be exponential plus beta L, where plus beta represents amplification coefficient. In the thermal equilibrium condition, alpha represents attenuation coefficient. In non-equilibrium condition, in inverted condition, beta represents amplification coefficient. These are the two extreme isolated conditions given here for simplification. So, you understand both processes, how light gets attenuated where there is thermal equilibrium, light gets amplified when there is inversion in the medium. In reality, when you do laser process, both attenuation and amplification both will take place. Then I would say I naught by I, that is, if I have a medium which is capable of attenuation and amplification, and if I put a green light, when this medium is capable of producing attenuation and also amplification, then I have to do like this one, exponential plus beta minus alpha L plus beta minus alpha, let us call it as a gamma. This gamma is a net gain coefficient, net gain coefficient. So, the intensity will grow as I naught by I will be exponential gamma L, where L is the length of the medium, and this is called the optical gain. Now, let me explain this particular process giving an example with which you are all familiar. Imagine that you are all graduates after your MSc or MS degree. Imagine that you have got a graduated, you go and tell your father that I have done my college education, I am ready to earn, I am ready to make some business. Then you request your father that you give me some initial input, then I will make business. Imagine that your father is very generous, very rich also. Let us imagine he gives you 10 lakhs rupees to start the business. You take this 10 lakh rupees, then go away from the parents, start your own business, and then after 3 years you come back and say that I have got 10 lakh rupees, please accept it, my business is doing well. If you say that one, your father will be happy or not happy? Certainly, if I do this for my sons, I will be very happy, because whatever I have given, I have got back. Then The business is called the threshold business. The business is a steady state condition. It is a good business, not an excellent business. It is a very, very good business. Because why? I tell you why. I gave 10 lakhs rupees to my son. He went out from Chennai. I can say he has gone to Bombay. He has earned his, he has established business, and then after 3 years he has married. He has got children. He is able to pay for the employees. He is able to pay for so many expenses, and after all this, he is able to come back and give me same 10 lakh, means he is capable of running a steady business. That is the meaning of this one. This is called the steady state condition of operating a laser. Why we say steady state condition is, during this process 1 minus R1 times N1, multiply only that one, 1 minus R1. R1 is a reflection of mirror R1. 1 minus R1 represents the amount of light that has come out. 1 minus R1 multiply by N tells you the number of photons that has been taken out. H nu represents the energy of photon. So, all put together multiplied, it represents the energy useful laser output that you got in. That means, I switch on the laser, this is the quantity of photons which are coming out, this is the quantity of output that comes out, then it is in a steady state condition. This is what happens when you switch on your helium neon laser or a CO2 laser. In a typical helium neon laser, you will get a steady output of about 5 milliwatt constantly coming out. This is the stimulated laser output which you are getting it, but how do you get it? You are supplying energy, electrical energy from the wall plug. What you get is a continuous coherent laser output which is an optical energy. This cannot come out from nothing, it has to come out only from the energy that you have given. The energy that you have given is an electrical energy from the wall plug. If you give about 1 watt energy, you will get about 5 milliwatt of optical energy. That is the simplest explanation for a steady CW laser action. So far, I have given a very simplified, remember it is not a simplistic picture, it is a real picture, it is a simplified picture of how a CW laser, continuous wave laser, just an example like a helium neon laser or your diode laser or a CO2 laser works. This is the essential feature where the spontaneous emission photon generated within the laser device gets stimulated emission. The stimulated emission is selected number of times, so that only a narrow band of frequency get a coherent activity, coherent stimulation, and out of 1 million photons running back and forth producing stimulated emission, only about 10,000 photons are coming out as a useful output. That's the essential feature of any laser. Thank you.